Reactions of monosaccharides. The first reaction involves the oxidation to produce acidic sugars. Monosaccharide oxidation can produce acidic sugars. Examples of weak oxidizing agents include toluenes and Benedict solution. They will oxidize the aldehyde end of an aldose to give aldonic acid. Oxidation of the aldehyde end of glucose will be producing gluconic acid. Oxidation of the aldehyde end of galactose will produce galactonic acid. Based on the given picture, we will see the D-glucose. The functional group of D-glucose is an aldehyde. What will happen upon oxidation? It will add an additional oxygen, forming carboxylic acid. Once it became a carboxylic acid, it will now be called an aldonic acid. As a result, the name of the glucose will be gluconic acid. This is an example of an acidic sugar making use of weak oxidizing agent. With toluene solution, glucose reduces silver +1 ion to silver. With Benedict solution, glucose reduces copper 2 positive ion to copper 1 positive ion. Thus, a reducing sugar is a carbohydrate that gives a positive test with toluenes and Benedict solution. What if we made use of a strong oxidizing agent? Strong oxidizing agents can oxidize both ends of the monosaccharide. Let us take a look at the picture. Since they are strong oxidizing agent, the aldehyde group will be oxidized. Thus, it becomes a carboxylic acid. This will be on the first terminal end. Next, what happens to our primary alcohol that is found on the terminal end? There will also be an addition of an oxygen, forming carboxylic acid. Thus, they produce dicarboxylic acid. Such polyhydroxy dicarboxylic acid are known as aldaric acid. For glucose, the oxidation will produce glucaric acid. What about if an enzyme is being used? In biochemical systems, enzymes can even oxidize the primary alcohol end of an aldose, such as glucose, without oxidizing the aldehyde group in order to produce alduronic acid. Let us take a look at the picture. The aldehyde group is not affected. What is being affected is the primary alcohol that is found at the terminal end. There will be an addition of an oxygen forming carboxylic acid. From D-glucose, it will now become an acidic sugar. Thus, we have the name D-glucuronic acid. The next reaction will involve reduction to produce sugar alcohol. The carbonyl group present in the monosaccharide can be reduced to a hydroxyl group using hydrogen as the reducing agent. For aldoses and ketoses, the product of the reduction will be the corresponding polyhydroxy alcohol. This is sometimes called the sugar alcohol. Let us take a look at the picture. Again, our example is the D-glucose. What happens with our aldehyde? It now transforms and becomes an alcohol. So, from an aldehyde, it became an alcohol with the addition of our reducing substance, which is your hydrogen. This is a reducing agent. Thus, our D-glucose will now become D-glucitol, or this is otherwise known as sorbitol. The next reaction will be glycoside formation. The general name for monosaccharide acetyls is glycoside. A glycoside is an acetal that is formed from a cyclic monosaccharide by replacement of the hemiacetal carbon hydroxyl group with an OR group. Glycoside that is being produced from glucose is called glucoside, whereas for galactose, it will be called galactoside. Let us take a look at the picture. There are two monosaccharides that are being bonded together. We have the beta-D-galactose and the alpha-D-glucose. What happens is that the carbon 1 of the beta-D-galactose and the carbon 4 of the alpha-D-glucose will be linked to each other. So it will be the oxygen that will link our carbon 1 and carbon 4. They are now called beta 1,4 glycosidic bond. Last chemical reaction involves phosphate ester formation. A hydroxyl group of a monosaccharide can react with inorganic oxyacids to form inorganic esters. Esterification of hemiacetal group, specifically in the carbon 1, and the primary alcohol, which is found in the carbon 6, produces compounds glucose 1-phosphate and glucose 6-phosphate respectively. So what we see on the picture, we have a glucose sugar that bonds with a phosphate group. If it bonded with the first carbon atom, then it is called glucose 1-phosphate. Whereas, if our phosphate group will bond with the 6th carbon atom, then we call it glucose 6-phosphate.